I am a high school student in Korea. I greatly enjoy watching your YouTube channel. I'm writing to share with you a math problem from the Korean SAT called CSAT, College Scholastic Ability Test. This problem is from the 1997 CSAT, a test that is known for having harder questions than other years. I'm curious to know how you might solve it. Thanks in advance. Hyungchun. I try to pronounce every name correctly, but if I didn't get it correctly, we can say HJ. This email and problem have been slightly edited for presentation purposes. So here's the problem. The diagram illustrates a right circular cone-shaped mountain. If you build a shortest distance track for a sightseeing train around the mountain, in which the track starts at point A and ends at point B, the track will first go uphill, but then it will go downhill. What is the length of the downhill track? Wow, even this problem is pretty complicated to understand. But lucky for you, it's multiple choice. So there are 4 possible answers. 200 divided by the square root of 19, 300 divided by the square root of 30, 300 divided by the square root of 91, and 400 divided by the square root of 91. So I will say this problem was very challenging for me. But can you figure it out? Give this problem a try, and when you're ready, keep watching the video for a solution. So this problem took me at least 5 attempts before I solved it. There's no way I would have solved this problem in a test setting. And here's some of the failed attempts. I first thought the cone unwrapped into a triangle. Next, I used coordinate geometry, but I failed to put the points A and B in the correct positions. The third mistake is I then made many mistakes in trying to calculate the equations of the lines. This led to many messy calculations. The fourth mistake is that I messed up how to find the length of the downhill track because I tried to do it by bisecting the line AB. This is not correct. I then tried to solve it by bisecting the circular arc to find the downhill track. So I was stuck, and then I said, maybe I should try and find the answer online. But then suddenly it hit me. Eventually I figured it out. I then also found an easier method to solve the problem, which I am presenting to you. The coordinate method is linked in the description. So why am I sharing this story with you? The lesson is that don't give up if you can't solve a problem. And also, don't peek at the video solution too early. Challenging problems often require persistence, but with practice and by solving problems on Mind Your Decisions, you will get better and you will become great at math. So, how do we solve this problem? The key insight is that a right circular cone unwraps into a circular arc. So here we have the cone-shaped mountain, and let's just imagine a general cone. If you cut open a right circular cone, it will unwrap into a circular arc. So here's a visualization of what I'm talking about. So we have this cone, and it's a 3-dimensional object. That makes the problem a little hard to visualize. It'll be a lot easier if we can make it 2-dimensional. So let's imagine we're cutting this cone vertically in the front. What will happen if we unwrap the cone? Wow! So this cone turns into a perfect circular arc. Now why is it a circular arc? The reason is that each point on the cone's base is the same distance of 60 from the cone's vertex. So here's the cone's base, and at the top is the cone's vertex. On the circular arc, we have the cone's base at the bottom and the cone's vertex at the top. Now each line on this cone's vertex to base, this slant height, exactly corresponds to a radius of this circular arc. So that's why we end up with a circular arc, because every distance from the vertex to the base is the same slant height of 60. And so this circular arc has a radius of 60. So now, how can we use this information to continue to solve the problem? Well, the first step is we're going to solve for the central angle of this circular arc. The radius of the cone's base is 20. That means its circumference is 2 pi r, which is 2 pi times 20, which is 40 pi. So that's the length of the circular arc. Now we know the radius of the circular arc is 60. This is capital R, or the slant height of the cone. Now there's a formula that relates the radius of a circular arc, its central angle, to its length. So the length of a circular arc is r times theta. So here, we know the length is 40 pi, and r times theta is 60 theta. So we can solve that theta is equal to 2 pi over 3. So that's the central angle. Next, we will place points A and B on the circular arc. So what happens when we unwrap this cone into a circular arc? Well, point A is along the base. So we know it'll have to be somewhere along the base of this circular arc at the very edge. Point B is 10 units from the base, and the track goes around the cone. So point B is going to be on the opposite side of where we place point A. So let's place point A on the right-hand side of the circular arc. We want to place point B on the other side of the circular arc and 10 units away from the base. So it'll be 10 units from the end of the arc, and it'll be 50 units from the vertex, because the radius is 60. Now, what's the shortest path from A to B? Well, in this circular arc, the answer is simple. It's a straight line between points A and B. So now, we're going to solve for the length of AB. We draw a straight line between A and B. So how can we solve for this length? We can use a little bit of trigonometry. Let's consider this triangle. We know 2 of its lengths, and we know the angle between those sides. So we can use the law of cosines to figure out the length of the third side. C squared is equal to A squared plus B squared minus 2AB times cosine of capital C, the angle between those two sides. So here we have the length of AB squared is equal to 60 squared plus 50 squared minus 2 times 60 times 50 times the cosine of the central angle 2 pi over 3. We can simplify this to get AB squared is equal to 9100, which means AB is equal to 10 times the square root of 91. So we're making good progress. But now, what is the downhill portion of the track? We know the total length of the track, but we're asked to figure out the downhill portion. So the uphill part of AB is increasing distance from the cone's base, which is equivalently decreasing distance to the cone's vertex. The downhill part of AB is decreasing distance from the cone's base, which is equivalently increasing distance to the cone's vertex. So if we draw some slant heights, which will be represented as radii on this circular arc, the uphill portion will be decreasing distance to the cone's vertex, and then the downhill part will be increasing. Furthermore, the downhill part of AB begins when the line is closest to the cone's vertex, and that'll be perpendicular to AB. So this will be the point at which the track goes from going uphill to going downhill. Now, we are already given that the track goes from uphill to downhill, and I use that information to then say, we'll look for the perpendicular, and this has to be the point. But to truly prove this problem for extra credit, you can prove that the track goes uphill and then downhill. And I'm sure some of you who think all of these problems are easy will be able to figure this out. You know, it won't be very difficult for you, but it's actually a little bit of a complicated thing to show. Anyway, this is a test question. We're going to use this information that was given to us and then continue to solve the problem. So now, how do we figure out the downhill length? We again use some geometry. Let's label the downhill portion x. The uphill portion will be 10 square root of 91 minus x. And let's label the distance from the vertex to the line AB as h. By the Pythagorean theorem, in one triangle, the uphill portion, we have the quantity 10 times the square root of 91 minus x squared plus h squared is equal to 60 squared. And in the downhill triangle, we have x squared plus h squared is equal to 50 squared. Now there's a neat trick. We can subtract the second equation from the first, and we'll cancel out the h squares, and we'll also cancel out the x squares. So this will simplify to be 9100 minus 2 times 10 times the square root of 91 times x is equal to 60 squared minus 50 squared. We can then simplify this equation and then solve to get x is equal to 400 divided by the square root of 91. And that's it. That's our answer. So the correct answer is 4. 400 divided by the square root of 91. So this is an incredible test question because there are so many concepts that you need to know in order to solve this correctly. But it was very satisfying for me to learn all these things about a cone, how to figure out the downhill portion, the uphill portion, and I hope you also got some of that discovery while solving this problem. Now, did you figure it out? And what method did you use? Thanks for watching this video. Please